I took a class called non-Euclidean geometry. Go figure, right? It was different geometries that aren't Euclidean. So you realize, oh wow, everything that I thought was the universe of geometry is only just one little piece of a bigger, there's other geometries out there. So I just want to point that out because, you know, we are still working within a specific framework, but there are other frameworks that are applicable to the real world. Like, I know there's a lot of people who play video games, right? I'm sure there's people in here who play video games. When you play a video game back in the 1980s and 90s, this is the video game you're playing, right? Frogger or something like that. Now, right, you're like immersed in this world on a flat screen that's making you think you're in three-dimensional space. It's all perspective geometry. So there's a lot of math that goes on with this. All right, I'm moving on. Circles. I can give you one more example. One more, sorry. I'm gonna do it, just do it. How many of you have ever, and we're getting ahead of ourselves a little bit here. If I draw a triangle, do you all know what the sum of the angles on the inside of the triangle has to be?
180.
180. Okay, all the angles together has to be 180 for any triangle. You're taught this no matter how you draw a triangle. All these angles have to add up to be 180, all right? So the sum of the angles is 180 degrees. Now we are going to talk more about this later. Right now we're acting like we don't even really know what a degree is. Right? We have to define what a degree is later and all that. But I think most of you have seen this before. This is true in Euclidean geometry. Would you like to see a place where it's not true? Yeah? Okay, we live, right? We live on a sphere. Yes? We live on a sphere. Roughly a sphere. Right there, it's not perfectly spherical, but so imagine that you travel from the North Pole down to the equator. You're going to travel along a curve, right? You're going to be, you know, driving, walking, whatever. It's going to look like a straight line, but really you're going along a curve, aren't you? Okay? And then let's say you drive along the equator, and then you decide to go back to the North Pole. Can you all see, or do you all kind of buy into the idea that that is a triangle on a sphere? That's what a triangle on a sphere looks like? Yeah? Do you buy that? It's like a patch on the outside of the sphere. It's a triangle, but the angles add up to be more than 180. Because this angle right here is 90 degrees. Because you're coming around the equator, then you go straight up. That's a 90-degree angle. And so is this one over here. That's 90 degrees. That's already 180. And you're only two of the three angles. So whatever this angle is up here, those add up to be more. So in different geometries, this is called spherical geometry. The sum of the angles in a triangle does not have to be 180. So anyway, for those of you who are moving on and doing more engineering, yeah, engineering, I mean, we cannot live in Euclidean forever. Like, you have to be able to go outside of Euclidean because, you know, if you live on a sphere, it's better to use a geometry where it lines up with where you are, right? Three-dimensional space, not flat sheet of paper. We don't live on a flat sheet of paper. All right, circles. Let's go back to Cartesian. Okay, we're back to Cartesian. We're back to two-dimensional space. Are y'all okay with me with that those little tangents? I don't want to, okay, because I don't want to lose you, but at the same time, I enjoy talking about that stuff. All right, circles. We all know what a circle is? Somebody define it for me. 360 degrees? So an angle is measured by how far you go around. So if I just go around 360 degrees, I'm not sure what you mean by that being a circle. I'm with you, I'm challenging you, okay? So I don't see the circle. Where's the circle? I'm starting somewhere, I'm going around 360 degrees. There we go.
set of all points in the Cartesian point that are at fixed distance r.
There we go. Yeah. Say that to me in layman's terms.
Every point r away
From?
from the center.
So you have some point, right? You have some point that we're going to call the center of the circle. So this is some point, right? Some point. Now we could label it xy, right? But it's the center of the circle. So because it's the center of the circle, we have a special label for it instead of x and y. We call it hk. Okay? I didn't make this shit up, okay? So someone decided h and k. Right? They could have used any letters they wanted. They used hk. Right? That's the center of a circle. This point is actually not part of the circle. This is not part of the circle. This is the center of the circle. The circle is actually, say again?
Set of all points.
The set of all points that are
R away.
that are a distance of r from this point. So imagine we take some measuring instrument, right? And let's say this is r. From here to here is r. A circle is all the points that are this distance r from some center point. So if I measure from here to here and draw a point, that point lies on my circle, right? But it's all the points that are this distance away. So I could continue drawing more of them, right? And you get the idea. If I swing this all the way around, that's where the 360 kind of idea comes from, is that if you take all the points that could be possibly a distance of r from that center point, you draw a circle. This is not going to turn out good, I can already tell you. Yeah, it's not turning out good. Yeah, there's my circle, all right? It's all the points that are some distance r, lowercase r, from some central point. That's the circle, all right? Now over on the screen over here, you can see that same picture, okay? If I change r, right, I can make r bigger or smaller. I can move my h and k, which will dictate where the center of the circle is, right? So the question becomes, what is the equation of a circle? We know the equation of a line, right? I gave you 3 equations. Y equals mx plus b. Y minus y1 equals m times x minus x1. And I gave you, what was the last one? ax plus by equals c, right? I gave you 3 different versions of a line. Is there an equation that represents a circle? Yes. Here's what it is. X minus h squared plus y minus k squared equals r squared. That's it. That's the equation of a circle. Know it. Okay, that's the equation of a circle. Here, the center of the circle is the point hk, and the radius is the r. Show of hands. How many of you have seen this before, this equation? A few of you? Okay. So what I'd like to do now is I'd like to draw a circle for you, and I'd like for you to tell me the equation of that circle. All right? I give you the circle picture, you give me the equation. Here we go. Example. Find the equation of this circle. No. It's hard to tell from my picture, but it just barely is touching. I'll put it up here so it's easier to see. There we go. That's the more precise picture over there. All right. Where's my folder? Did it get around to everyone? Did everyone sign in? Need it back over here? And where are all the things? Are in here? So you are supposed to turn in a quiz today. That was a group quiz from last time, and sign in at the same time. Anyone here need it? Need it here? Did you sign in already? Okay, just put that there. Group quiz, sign in. So sign here, and then put your quiz with that stuff. Okay, who wants to volunteer? Go ahead, sir. I'll get to
So, since your circle's center is 3, 3, you would plug 3, 3 into your equation for h and k.
Okay, let me do that. I'm going to start that right here. So I'm going to go x, you tell me.
Well, 3.
Minus 3, that quantity
Yeah,
squared, plus
y minus 3 equals r, or squared equals r squared.
equals r squared. Do you know what the radius is?
Yes.
How can you tell?
Well, the circle's center point is 3, 3, and both of your side points are literally 3 away.
That's right. We know that this is 3 this way, right, and 3 up, so you know the radius, don't you? It's not explicitly given to you, but you can tell from the geometry that this distance here is 3, right? Which means this is 9, right? Because the formula says it's radius squared. So this should be, can I put 9? I just put 9, is that okay? 9, boom, we're done. Okay, we're done. That is the equation of that circle. We won't make this more complicated than it has to be, right? Ready for another one? How about this one? I'm telling you that this point right here is square root of 8. If you want to look at it like a point, it's the point square root of, oh, that's terrible. It's the point square root of 8, 0. And I'll put it up here as well. 0, square root of 8. Give you a second to look at it. I'm telling you that this is a circle, all right? I'm telling you that. That's important because if this could be an ellipse, and then if it's an ellipse, then you wouldn't be able to tell me the equation. So this is a circle. I've given you 2 points on this circle. Who's my volunteer on this one? I need different volunteers each time. If you wait too long, the problems start getting harder. Go ahead.
X minus square root of 8 squared plus y.
Let me do this. Can you tell me what the center or the radius is of this?
Oh, the center is 0, 0.
The center is 0, 0. Everyone agree? The center is the origin. So when it comes to HK, it should be 0, 0, right? I'm going to put that here. HK in this problem is 0, 0. Okay, now can you tell me what the radius is?
Square root of 8.
Square root of 8. That's the distance from here to here, right? So square root of 8. Once you have what h and k are, and you have the radius, you just plug into the formula.
Okay.
You want to tell me still?
Yeah, x minus 0 squared plus y minus 0 squared equals 8.
Equals the radius squared, right? Which turns out to just be 8 because you're squaring this. Square root 8, if you take the square root of 8, it goes away and you just get 8. That okay? Now, do we really need the minus 0? Isn't x minus 0 just x?
Yeah.
And isn't y minus 0 just y?
Yeah.
So why don't we just write this instead? X squared plus y squared equals 8. Isn't that a very nice way of looking at the equation of that circle? This is just x squared plus, this is just y squared and then equals 8. So just write it that way instead. Wouldn't our formula look like this? If the center was 0, wouldn't it always look like this, x squared plus y squared? If it was centered at the origin, it would always be x squared plus y squared and then the radius squared. When our circle is not at the center, when the center of our circle is not at the origin, then it's going to look nasty. But when it's centered at the origin, it's actually pretty nice looking. Okay? Ready for another one? I'm going to give you 2 minutes. No, 3 minutes. No, 4 minutes to see if you can talk amongst each other to get this one. I'm going to give you that the center of this circle is 2, 3. All right? And then I'm going to give you that this point on the circle is 5, 7. I want the equation of this circle. Think about it. Talk to each other. What are the 2 things you need to know to find the equation of a circle? You need to know the center and you need to know the radius, right? If you know the center and you know the radius, you are in business. Right? Okay. Enjoy. 4 minutes. Let's see if you can get it. At least get to how you're going to do it. Talk to each other. Help each other out. Show of hands, how many of your tables groups got it? Or got at least the idea of what to do? Yes? What's the problem? Are y'all having trouble finding the radius?
Yes.
Isn't the radius just the distance between these 2 points?
Yeah.
Do you know how to find the distance between 2 points?
Yeah.
Yeah, right? I gave you a formula. We talked about that earlier today. Right? You have to figure out what the distance between these 2 points is. So you have to do that computation with the formula we used earlier today. Yay or nay? Okay, so we know the center, right? Right, the center here is HK, which for us is 2, 3. So we've got a lot of it already taken care of, right? We've got this taken care of. We know what H is, we know what K is.
Yes.
We just need to know R, right? So R, we don't know. But this is R, the distance between those 2 points. So we used the formula from earlier. Now, in our formula, we called it D, didn't we? Not R. But it said D is equal to the square root of the, what was it? X2 minus X1 squared plus Y2 minus Y1 squared, right? That's our distance formula for the distance between 2 points. Now we have to label our points however we want to label them. X1, Y1, X2, Y2. That's the way I'm going to label them. And then I just plug everything in. So X2 for me is 5. Take away X1, which is 2. Square that plus Y2, which for me was 7, and then take away Y1, which was 3, and then square that. This is just square root of, see, that's 3 squared, 9, plus this is 4 squared, that's 16. Isn't that just 25? And the square root of 25 is 5, right? I just made this problem up. I wasn't even trying for this to be a nice number. It just happened to work out that way. So we know the radius, don't we? The radius is 5. And once you know the radius, what? You got it, right? Just go and plug into this formula right here. So here's the answer to this one. X minus, what, 2, right? Squared plus Y minus 3 squared equals, careful, 25. R squared, 25. There it is. Do y'all believe it or not? Do y'all believe that's the answer? Let's ask Desmos to graph it. I'm going to graph x minus 2, squared plus y minus 3 squared equals 25. Whoa, what the hell? Is that point here? Where's this point? 5. Is 5, 7 on this graph? Do you see it there? You see 5, 7 is on that graph? And then the center, let me hide the other one. The center of this circle is the point 2, 3. There. Does that look like the center? Yes. So what would you say? My drawing was not very good, was it? I gave you the information you needed, right? Center 2, 3, point on the edge of the circle is 5, 7. But in reality, the only way that circle can exist is if it looks like this. Yeah? Okay. One more? I'm not going to do group. I'm going to just have you think about this one. Last one. What if I gave you a circle Here's the center. I'm not going to give you the center. Okay, what I'm going to give you instead is I'm going to imagine cutting through that center with a straight line, like this. And I'm going to give you this point right here. That point right there is the point, let's go 2, 5. And this point right here is the point 1. No, not 1. That can't be 1. That's in the wrong position. Let's go with 6, 3. So not drawn to scale here, all right? Not drawn to scale. But can you find me the equation of that line? So I need a new volunteer to help me think through this. What are the two things you need to know to find the equation of a circle? Center and radius. Do you have either one of those? Right now, just the way it's presented. Do you have the center or the radius? No. Okay. So what do you want to go after first? Center? Okay, how are you going to find me the center of that? Midpoint, right? That's the midpoint, isn't it? Okay, so you find the midpoint between those 2 points, and that will be your center. And then once you have that, then what can you do to get the radius? The distance from that center to either one of those points, right? Your choice. There you go. So let's do our midpoint. I think I made this so it'll work out. Nah, it's not going to be very pretty, but so HK for us is actually just the midpoint of the point 2, 5 and 6, 3, right? That's really what it is. The center of our circle is actually the midpoint of those 2 points. And to find the midpoint, it is the average, right? The average of the x coordinates, average of the y coordinates. So someone give me the x coordinate, or the h. Someone give me the h. What is it? 4, right? You're doing 2 plus 6. Add up the x coordinates. 2 plus 6, divide by 2. The y coordinates, you add them up. 5 plus 8, 5 plus 3, divided by 2, right? So 8 over 2, 4. God, what the hell? Is it 4, 4?
Yes, sir.
It's 4, 4. Okay. That's your center. So this is your HK. Now, to get the radius, we're going to find the distance between this point and either one. Doesn't matter. Whichever one you want to use. So which one do y'all want to use? 2, 5 or 6, 3?
2, 5.
You want to use 2, 5? Okay. If we're going to use 2, 5, and then this point is now 4, 4, would y'all like to label this one x1, y1, x2, y2 for our distance formula? Is that okay with you? All right, I'll do that. By the way, it doesn't matter which, if you label it the other way around, you're going to get the same answer. Right? So I'm going to label this one x1, y1, this one x2, y2. Right? And now I'm using the distance formula. I'm going to go ahead and erase this because I think I've been through this enough here. To find the radius should be equal to the square root of, notice I'm using r instead of d, because the distance we're looking for is the radius. So I'm just going to call it r now. And then it's the difference of the x coordinates squared plus the difference of the y coordinates squared. So what goes in here? What's the first number that goes in here? 4 minus 2, right? So 2 squared. And what goes in here? 4 minus 5. So 4 minus 5 is -1. Do I need to show where those come from? Do I? You're all right? And so this should be square root of 4, that's 4, right? And then plus -1 squared is 1, so this is just r is the square root of 5. right? So we're ready for our final formula, right? The equation of the circle is parenthesis x minus 4 squared plus y minus 4 again squared equals the radius squared. There it is. If I graph that on Desmos, which I'm about to, I should see a circle oh shit, what the hell just happened? What we should see here is a circle that goes through 4, 4. It should have a point, what's that, 0.25 should be on this circle. There it is. And the 0.63 should be on that circle as well. See? All I gave you were the 2 points, and we were able to recover the entire equation of the circle. Any questions? So do you feel pretty good that if I gave you a picture and some information that you could recover the equation? Yeah? How about the other way around? What if I gave you the equation? Could you recover the center and the radius? Probably pretty easy, yeah? Let's try it. Careful what you wish for, though, okay? Seems like this is going to be easier, right? If I actually just give you the equation for you to be able to tell me the radius and the center, right? It seems like this is going to be easy. And initially it is. Initially it is easy, but then it gets hard, all right? So hang tight. I want us to find the center and the radius of this circle.